our partial math project. My name is Gabriela Gutierrez.
I'm Roberta Cadena,
And I'm Cordelia Gonzalez.
and we're doing problems 3 and 8.
We will begin with problem 3. The range of a projectile is expressed by this function, where VO is the initial velocity in feet per second, and the angle is the angle of elevation. And in this case, it was changed from 10 degrees to 11 degrees. So first of all, we have to find the change in the range of projectile 1.
Okay, the change in the range is expressed as delta R, in which we subtract the formula first with angle 2, which is 11, minus
The function with angle 1.
which is 10.
So I'm going to start plugging it into my calculator so we can get the result.
2,500 to the second power over 32 times the sine of 22 gives
73,
73, 165.35.
35. And we're going to do the same thing, but with the original value, which was 10 degrees. So instead of 22, it will just be 20, because 2 times 10 is 20. And the result will be 66,800.8.
So we subtract this minus this, and the answer is
63,064.55.
this is the change in the range when the degree changes from 10 to 11 degrees. Now we're going to use differentials to approximate the value of the change in the
Range. So what we'll have to do is take out the derivative of this function.
and multiply it by dx. So we have dr is 2,500 to the second power over 32. The derivative of sine 2x is 2 cosine
Of the angle.
2 times the angle times the angle. We substitute.
So the answer is 367,067.43. So now we will proceed with explaining what just happened here.
We can see that the difference between delta R and dr is very great, because this is just an approximation of the range, and this is the exact difference between
10 degrees
10 degrees to
11 degrees. And we have asked many experts in the subject, and they explained that sometimes it is not appropriate to use differentials to approximate, because if you use a cost graph, many times the values will be situated in places where the variation is much greater. So in this example that was with projectiles, it's not appropriate to use differentials. We would much rather just find
the exact value by using delta R. We're going to integrate the following formula.
First, we're going to rewrite by using a binomial special product.
We're going to pass our variable to the top using a negative exponent. This is a way of rewriting, so it is easier to see our terms and integrate.
Now we're going to use power rule to integrate. You leave the coefficient alone and then you write the variable with the exponent plus 1 over the same. And you write plus c
To represent a constant, because a constant derivative is always 0. So you have to
write a variable to represent that there could be a number there. Now we're going to simplify. And now we're going to rewrite by passing our negative exponents to the denominator. And that will be our final answer.